So welcome. In this session, you're going to discuss how to represent complex numbers on a diagram. And the diagram we use to represent complex numbers is called the Argand diagram of the complex plane. So for any given complex number, we can always represent it in a plane, just similar to the way we represent points in the Cartesian plane for the case of real numbers. So to every point in or on a real line corresponds to a real number, and also any real number corresponds to a point on the real line. A similar relation exists between the set of complex numbers and a plane, and to any given point with coordinates a, b in this plane, it corresponds to a complex number a plus bi. So when a plane is used, to represent complex numbers, it is called complex plane, or complex number plane. The other diagram, the other name is of this diagram is called the Argand diagram, or the ghost plane. Then in this Argand diagram, the horizontal axis is called the real axis, while the vertical axis is called the imaginary axis. And so we can give a picture to a picture which actually represents this. So this is what you are calling the real axis, and this is what you are calling the imaginary axis. So here we label as I, 2i, 3i, etc. And then this will be negative I, negative 2i, negative 3i, etc. And then this negative 1, negative 2, negative 3, negative 4, etc. 1, 2, 3, 4, etc. So that is how an Argand diagram looks like, or how a complex plane looks like. The vertical axis has labels of imaginary numbers, and then the horizontal axis has the usual real numbers that define the complex number. So as an example, plot the following numbers on the Argand diagram. So Z1 is 2 plus 3i. Z2 is 3 plus I. Z2 is minus 2 plus 4i. This is Z3. Z4 is minus 2 minus 3i. And Z5 is 4 minus 2i. So these 5 numbers will help us to understand how we usually, in general, represent numbers in Argand diagram. So you draw the vertical axis. Draw the vertical axis and draw the horizontal axis. So the horizontal axis is what we call the real axis. And then the vertical axis is what we call the imaginary axis. So let this be I, this be 2i, 3i, and this be before I. This is 0, negative I, negative 2i, negative 3i. This minus 1, minus 2, minus 3, minus 4, minus 5, etc. This is 1, this is 2, this is 3, this is 4, and let this be 5. So to plot the point Z1, given as 2 plus 3i, means on the horizontal axis, you are at the point 2, and you move parallel on the positive y-axis 3 units. So 3i is here. So this 3i, and then where it meets, so this is what you plot with small x. So this way we'll have our Z1, the point 2 plus 3i. Then Z2 is 3 on the x, on the real axis, and I on the y-axis. So we'll have I on the y-axis, and then 3 on the x-axis. So where those two lines meet, so this way we put Z2. And then Z3 is minus 2 on the x-axis and positive 4 on the y-axis. So 4 is here, 4i, then minus 2 is here, go up. So where the two lines meet, you put Z3. And then Z4 is minus 2 on the real axis and minus 3 on the y-axis. So minus 3 is here. Then this minus 2. So where they meet, that's what we call Z4. And Z5 is 4 on the real axis, minus 2 on the imaginary axis. So minus 2 on the imaginary axis is this line, and 4 on the real axis is this line. So where these two meet, you put Z5. So that is how generally we plot complex numbers in an Argand diagram. Assuming we had a Z6 given by say you have Z6 given by 2i. So 2i means that the real part is 0, so you are just on the y, or you are just on the vertical axis. So the Z6 will be here. And then if you had Z7 given as just 1, then Z7 will be here on the real axis. So that is generally how we do the plotting on an Argand diagram. So a question, show Z and Z conjugate on the Argand diagram for Z equals to 3 minus 4i. So they want us to draw a Venn diagram and represent Z and its conjugate. So from what you have discussed earlier on, you know that if Z is 3 minus 4i, then what we call Z conjugate will be 3 plus 4i. So it's like 3 minus 4i and 3 plus 4i on the same plane. So draw this as our vertical axis. So this is our real axis. This is our imaginary axis. So 1, 2, 3, 4. So I, 2i, 3i, 4i, 5i, 1, 2, 3, 4, 5, 6, 0, negative I, negative 2i, negative 3i, negative 4i. Then we have negative 1, negative 2, negative 3, negative 4, negative 5. So Z was given by 3 minus 4i. So 3 on the real axis minus 4i on the imaginary axis. We'll have, this way have minus 4. And this way I have 3. So this number will be here. So this way I have Z. And then the conjugate of Z is 3 plus 4i. So 3 on the x, 3 on the real axis, and 4i on the imaginary axis. So I'll have this. So this number will be here. So that is how those two numbers are represented. And we know that, which is always true in general, not in the Argand diagram, conjugate of Z is a reflection of Z in the real axis. So the equation of conjugate of Z is an image through the real axis on the Argand diagram. Then number 3, or another example, let Z be given by 3 plus 4i and W be given by 2 minus 2i. Show ZW and Z plus W on the Argand diagram. So what we do here first, let's get the sum and then we draw the diagram. So solution, Z plus W, simply add the real parts. So 3 plus 2 is 5. 4i minus 2i is plus minus 2i is just actually 2i. So the sum is 5 plus 2i. So what you are going to do is to draw an Argand diagram and show these three complex numbers, 3 plus 4i, 2 minus 2i, and 5 plus 2i. So let this be the real axis. This be the imaginary axis. So 0, I, 2i, 3i, 4i, 5i. 1, 2, 3. So 1, 2, 3, 4, 5, 6, 7. I, 2i, 3i, 4i, 5i, say 6i, minus 1, minus 2, minus 3, minus I, minus 2i, minus 3i, minus 4i. So remember Z was 3 plus 4i. So 3 plus 4i means real axis, you are at 3. So real axis is 3. Y-axis is 4i. So this will be somewhere here. So this will have Z. And then W is 2 minus 2i. So 2 minus 2i is here. So this way you have W. And Z plus W is 5 plus 2i. So 5 here. 2i will be somewhere here. So Z plus W. So those are the three numbers. And if you are doing this on a graph and join these numbers, join this, join to this, and join this, and join this. If you do this one on a graph paper, on scale, you realize that this produces a parallelogram, that this side, and this side will be the same, this side and this side will be the same. And it's actually a shape of a parallelogram. So general result, when you represent two complex numbers and the sum in an Argand diagram, is that if a complex number, or if complex numbers if two complex numbers if three complex numbers, Z, W, and Z plus W are represented by points Z, W, and S in an Argand diagram, then O, Z, S, W is a parallelogram. That is always the result that we always obtain. Then last case, let z given by 3 plus 4i and w2 minus 2i show zw and z minus w on an Argand diagram. So the first thing, let's define the difference. So z minus w, 3 minus 2 is 1, 4 minus 2i is plus 6i. So then, if this is our vertical, the vertical imaginary axis, and this is the real axis. So this is the imaginary axis. So 0, minus I, minus 2I, minus 1, minus 2, 1, 2, 3, 4, 5, 6, 7, etc. I, 2I, 3I, 4I, 5I, 6I, 7I, 8I. Then Z is given by 3 plus 4I. So 3 on the real axis, and then 4I on the imaginary axis. So we'll have Z here. 2 minus 2I, so 2 minus 2I will be here. W, and then 1 plus 6I, our difference. So 1, and then 6I will be somewhere here. So then we see that this vector if you draw a vector from W to Z, if you are doing this thing on a square graph and you define this vector, this straight line, and then you have another vector from the origin, then you realize that those two vectors are always translations of each other. So if a complex number, if three complex numbers, Z, W, and Z minus W are represented on an Argand diagram by points Z, W, and S, then the translation which takes W to Z represents actually that's now this just we are respecting these two numbers, two complex numbers Z and W, which takes W to Z represents the complex numbers Z minus W. So that is what we have. So the next session will discuss about the modulus and fragment of a complex number, which can help us to express complex numbers in polar form and exponential form. Thank you.